Hello everyone. About the network layer, the typical protocol is IP, Internet Protocol, and it is used to define the encapsulation of packets, define the network node. And about this part, we have to know the IP address. What's the format? What's the classification? What's the subnet mask? So this is the first one. And the second one, we will know something about the routing and some typical protocol. Maybe I already think someone knows the information of OSPF, static, BGP, something like this. So what is the basic concept? And the third one, the typical protocol is ARP. If you know the IP address, how to get the MAC address. This is a function of ARP. And about the last part, we will talk something about the ICMP. Because I think some engineer already know the tools, ping and transert when you do the troubleshooting, right? Actually, we use the ICMP package to finish this function. So if you are interested, let's begin.
Before we talk about the detail of the IP principle, let's see the practice question of the last video, LAN principle. The first one, which of the following statements about the MAC address is true? The answer is A and C. So what's the wrong of the option B and option D? About the option B, a MAC address is a logical address that is easy to change. Actually, this is a definition of the IP address, right? And about the option D, usually only the terminal host needs the MAC address, and the network devices such as router do not. So this is wrong. All the network devices, including the router, the switch, the firewall, all the devices need the MAC address to transfer the packets. So this is the first question. And about the second one, in the following topology, all hosts can communicate normally, and no logical interface is configured on the switch. How many collision domains are there in the network? So let's review of the function of the switch. We say the switch to connect with the network devices, and one port is one collision domain. Because about the switch for the packets, we will check the MAC address table, and all the terminal connects with the switches. We can send out the message at the same time. But pay attention in this topology. Here is a hub. About the hub, we only can create the signal and send the information out. So we say about the hub to connect with the network, there also is a bus topology on the network. So this is a definition of the collision domain. Let's see how many collision domains in this topology. The first one is the left one, one hub, all of the devices within the same domain. And the second one, the third one, the first one, and the fifth one, then here. So about this, correct answer is option D. We have different collision domain, and in different circle, the terminals can communicate at the same time. But pay attention about the left three terminals. Only one device can send out the packets, and then the rest of the terminal we have to wait. Use the Sigma CD mechanism to avoid the collision. So this is the correct answer of the option D. Then let's see the IP principle. First, we have to know IP belongs to the network layer protocol, and this is the most widely used in the network protocol because I think everyone knows IP, right? If you want to become the engineer, Maybe you know IP is IP address. Maybe you know IP is IP protocol, and you know IP packet, something like this. And the second one, the IP protocol specifies the encapsulation methods of the date, and also identification method of the network nodes. It's used to transfer the packets end to end. That means, as we know, before we transfer the message to your next hop or to the destination, we have to do the encapsulation to add each layer header, right? So about the IP, we will define what's the information we need to add into the network layer. The source IP address, the destination IP address, and also includes the other information. So the detail we will talk later. And also we define the network nodes. We will use some router, some switch to connect with different segments, and how to forward the information between different segments. We also will use the IP. So this is very important of our network. And the second one, about the IP, we say this protocol belongs to the network layer. And the connection, the relationship of the IP, we also have the other information. For example, in this picture, about the transport layer, we need the IP to provide the service for the transport layer, right? The typical transport layer protocol is TCP and UDP, right? So there is a question. When the IP provides service for the transport layer, we have to know, we have to provide the service for TCP or for UDP. How to know this information? This is like I have a gift. I have to give my friend A or friend B. I have to know their name, right? Because if the gift, there is a name A, I will directly give the information of the A. So about your network, about the IP, how to know my app layer is which protocol? We have some information we call protocol ID. And the different app layer protocol, we have different ID. For example, if we use the TCP to encapsulate the packets, the protocol number is 6. But if we provide the service for UDP, the protocol number will become 17. And the other protocol relationship with IP, like ICMP and IGMP. About the ICMP, usually is used to test the network connection. For example, we will use a tool like ping, like traceroute, to test the ping successfully or not. And we also encapsulate the ICMP packets into the IP, and we will use the protocol number 1 to indicate the ICMP. And IGMP is used for the multicast protocol. And about this protocol, you only know used in the multicast is enough, because in the RCNA we don't talk about the multicast protocol, and the protocol number is 2. And besides this protocol, we also have typical protocol have the relationship with IP, and the one is ARP and IARP, and this one is very important. Because maybe in your network, you never do the configuration for the ARP, but before we send out the packets, the first step we use the protocol is ARP. So how to work, what's the function, we also will talk later in the video. This is the location of the IP. And the next step, let's see what's the function of the IP. About the IP, the first function is identify the node and the link. So like this topology, we have lots of terminals, right? And they may be located in different segments, and we will use multiple network devices to connect with each other. And here we have 2 types of the IP address. The first one is a detailed IP address to indicate the nodes, like the terminal 1, 2, 3, 4. We will use the IP address. And another one, we will use the IP network address to indicate the link segment, like segment 192.168.1.0, or the second one or the third one. So there is a question, why we use this format to indicate the IP address or IP segment, and what means IP network address, and how to get the IP network address, and this is the detailed part in the next video. So now we only know the function is identify the nodes, like the terminal, like the network devices interface, and also to indicate the link. So this is the first function. And about the second function of the IP, we will provide the addressing and forwarding function. So what's mean about this part? Also, there is a topology, right? We usually use a router or layer 3 switch to connect with different segment network. And the first one, an IP network consists of multiple network segments. For example, with the first segment is 192.168.10 and the median one is 172.18.10. So this one we call different network segment, and we will use a router to connect with each other. And each network segment corresponds to a link. Okay, of course, in the link, maybe we have the terminal. Maybe we have the terminal with router together. Maybe we only have the router. And the second one, the router will connect to the network segment, and then to forward the packets between different networks. Of course, besides the router, we also use a layer 3 switch, And about the layer 3 switch, also can do the function like the router. This is the second one. And about the third one of the IP can adapt to a variety of data link. Because about the router, we have multiple interface, like the Ethernet interface to communicate the LAN network. Maybe we can have some serious interface to do the communication with one network. And the typical function, the first one is IP packets are fragmented and resemble according to the MTU to the link. So what means MTU? MTU is maximal transmission unit. For example, maybe we design the maximal unit is 1500 bits, but actually we will send out the packet is oversized. For example, maybe you download a video, but the video total size is 1 GB. But on the link, you cannot directly send 1 GB packets on the link because this is too big. So we can divide the different packets according to the limit size to become 1500 bytes and 1500 bytes, something like this. And after the receiver receives this information, we can fragment again according to some sequence number. What's the first part, what's the second part. So this is a function of the IP. And the second one, we can establish the mapping between the IP address and the data link layer address. So this also is a function of the IP. And the typical application is IP address and MAC address mapping. This process we talk about the ARP. So this is a function to get the relationship between the IP and the MAC address information. Because when we do the encapsulation, we need this information. So this is the third part. And the next one, we have to know the IP datagram. What's mean? When we encapsulate the packets, we have to add each layer information of the packets, like the application layer, transport layer, and the network layer, something like this. And we already talk about the LAN principle, right? We know the detail of the LAN principle. When we add the information of the data link layer, we have to add the source MAC address and the destination MAC address, and also some type length, something like this. So about the IP header indicates the network layer header. So we have to know besides the source IP address and destination IP address, what's other information here. And each site we have the function. The first one is the first line. first part is a version. We have two types of version. One is IPv4 and one is IPv6. So the first one will define what's the next information we have to add. IPv6 and IPv4 is a little different. So if we use the IPv4, the version number will become 4. And the second one is IHL. IHL is the IP header length because we have to provide the service for the app layer, right? Maybe your app layer user protocol is TCP. So we have to delete the IP header. You have to know which range, which length belongs to the IP header. From the first bytes to maybe 20 bytes or maybe 30 bytes, you have to delete all the information. And who knows this information? We already added the length on the second part. And the third part is the types of service. This one is used in your QoS. So what means QoS? We can provide different priority of different service if your resources is not enough. For example, now your resources is not enough. Your link bandwidth only 100 Mbps, but now we have to send out 120 Mbps message. So we can divide different service. We have different priority. For example, we hope the voice data can be transferred at first. So we need the value to indicate the voice. We can provide different type of service. The voice number is 7, but the data number is 5. So we will transfer the 7 information at first. So this is a type of service. And the second part is totally length. The totally length indicates the IP header and the TCP or UDP. That means the app layer headers whole length. All the information here and we can delete the IP header, and from the next bit is the app layer package. So what's mean? For example, the total length is 100 bytes, and the IP header is 20 bytes. So that means the 21 we will belong to the app layer information. So this is a function of the total length. And about the second one, this line you only need to know we have these segments is enough. You don't need to know the detail function. This part maybe will use in when you send out the package. It's oversized MTU. We also have to let the devices to know we do the fragment of these devices. It's enough. And the detail we have to know is the third line. About the third line, first part is time to live. Someone maybe already sees this value when you do the network connection. You use the tool of ping, right? When the receiver gives you the reply, we can see some TTL value is 253 or maybe the other value. So this is a value of time to live. The time to live is used to avoid the loop. When you send out the message, for example, the router sent to the next hop, the TTL value will be delete 1, will be reduced 1. And the maximum number is 255. So if there is a loop, finally the TTL value will become 0, and then the packet will be deleted, will be discarded. So this is a function of time to live. Of course, when you use a tool like the trace route, you want to know what's the first hop, the second hop, the third hop, something like this. We also will send out the special time to live packets, and then to get the reply information to tell you what's the first hop IP address, what's the second hop IP address, something like this. It's very important. And you don't need to give special configuration. When you send out the packet, this value will be automatically added into the IP header. And the next part is a protocol. This protocol is very useful. We talk about the before page, right? And we see how to know your app layer protocol is TCP or UDP or ICMP or something like this, or maybe OSPF protocol. We will use these words to indicate different segments, different protocol. For example, if the protocol value, the segment value is 1, that means we now encapsulate the ICMP. If we use the protocol value is 6, that means we encapsulate the TCP protocol. So something like this. And the next part is header checksum. And about this part, when we send the information in your network, maybe someone will change your packets, or maybe because there is too long distance, so we change some bits. When receiver receives these packets, we can do some check. After we check the result is different, that means someone changed the information. We can ask the sender to give us a new packet, something like this. And the most important one is the next part, source address and destination address. This address indicates will show you where who sends you your IP packets and who will receive this packet. And also will let the router know if I receive this information, how to check my IP routing table and find the best path, and then which is out interface, something like this. So this part will directly let the network devices know how to forward the information. And about these two parts, this information is a fixed length, 20 bytes long. And of course, if you want to add the other information, maybe have some special function, you can add this information of the options or paddings. But at least the IP header length at least 20 bytes long. So this is IP datagram. And then now we already know how to encapsulate the packets, right? And what's the detailed information we have to add into the packets. And then the next part is very important one. What means the IP address? What's the format? And how to calculate? And how to plan the IP address? What's the IP address we can use? What's the IP address we cannot use? All the information we can know on the next video. We will talk about the detail of IP address. That's all about the first part. Thank you.